Okay, so this question asks you to complete and balance the equation and write the complete and net ionic equations. So you have to know a couple of things. You have to know solubility rules. You have to know what kind of reaction it is. In other words, it's a double displacement reaction. And have to know nomenclature, and you have to be able to write formulas. If you don't know all of that stuff, then you can't even begin to start writing a complete and net ionic equation. So I'm going to assume that you know most of those things because, especially nomenclature, that's something that you got from previous examples. And so you should be on the same page with me there. But it is a double replacement reaction, so we know that we need to swap the partners. So lead will get together with chlorine, and ultimately nitrate will get together with potassium. And so we have to write down those formulas. So I'm going to start with potassium nitrate. Now, this is where our solubility rules comes in. We have to know that that's aqueous. Then I'm going to write down the formula for the lead chloride that's formed, and I have to figure out what lead chloride it is. Well, in this case, it's lead 4, and so lead 4 chloride is PbCl4. Now, for the solubility rules, I would know that this is solid, and solubility rules are just something you're going to have to memorize. So you have to know what they are. Now, maybe you're in an introductory chemistry course, and so you'll have those solubility rules handy for you. But if you're in general chemistry, you really need to know them by heart. So the rest is balancing the chemical equation. And so I think I'd start off with some nitrates in this case. I know that I have 4 nitrates on the left, so I need 4 nitrates on the right. That definitely messed up my potassium. And so I need 4 potassiums on the left. And that also just balanced my chlorides. So I'm good to go on balancing. I'm good to go on writing the completing the reaction. And I'm good with the states and the chemical formulas. So now we want to move on to the complete ionic and net ionic equations. Well, the complete ionic equation is taking all of the different ions and writing them out as they appear in the solution. And remember, when we have an aqueous ionic compound, the individual ions are not together, they're apart. Now, if it's solid or gas or a pure liquid, then those atoms are connected together. And so we would just write them in that fashion. So remember, if it's aqueous, the numbers and types of ions are broken apart, and so we write them separately. But if it's solid, liquid, or gas, we leave it together as a complete unit. So let's see how that works out. In this case, I have 1 lead, and it's a lead 4 ion, and it's aqueous. It was together with 4 nitrates. And remember, you have to know the formula of nitrate in order to get this down, NO3 minus, and it's aqueous. I also had 4 potassium ions. They were aqueous. And I have 4 chloride ions, and they're aqueous. That's the reactant side. Now let's do the product side. I have 4 potassium ions. That's together with the nitrate. They're aqueous. I have 4 nitrates. They're also aqueous. But the lead 4 chloride is a solid, so I'll leave it exactly as it appears. Remember, because since it's a solid, the ions are not actually separated. So this is the complete ionic equation. I'm good with that. I have solved that part of the problem. Now, how do I get the net ionic equation? What's the deal with that? Well, the net ionic equation will represent only the actual ions that did any reacting. If they didn't change state, then they're called spectator ions. So what we need to do is find those spectator ions and cross them out and write what's left, and that'll be the net ionic equation. So anything that appears the same way and in the same quantity on both sides of the reaction can be crossed out. Well, look what we have. I have 4 nitrates in the reactants, 4 nitrates in the products. They're both aqueous, so we cancel them out. I have 4 potassium ions in the reactants, 4 potassium ions in the products. They're both aqueous, so I cross them out. Nothing else appears the same way on both sides. So what I'm left with must be the net ionic equation. And so the net ionic equation seems to be telling me that one lead 4 ion in an aqueous state got together with 4 chloride ions in their aqueous states to form a lead 4 chloride formula unit in the solid state. And that is the net ionic equation. And so I've done everything I needed to do for this problem, and so I'm done.